Now, I have a confession to make before I begin. I'm a Go beginner. So I've been looking at Go for about maybe, I want to say 2 months, but it's mostly only about 7 or 8 weeks. So please be gentle with me. So what I, my background, I'm really a Java developer. I'm showing my age. I've been in IT for a while. Let's try and use this thing, see if this works. Yeah, there you go. I'm ashamed to say I've been in IT for 30 years now. And started out as a COBOL programmer. Now, who's ever used COBOL? Wow, there's quite a few people, actually. I'm feeling pretty good. I'm glad I came, actually, now. But my primary career really was as a Java low latency engineer, so working on trading systems for investment banks. So just earned a bit of cash doing that, bought a house, did quite nicely. And then it must have been around about 2005 time, 2006 time, this is when I started to get into things that we know as in-memory data grids. So, and I'll explain to you what in-memory data grids are, because it's kind of a niche area that's off to the side of NoSQL, really. But these were some of the IMDGs I worked with. There's Oracle Coherence. So if you're from the enterprise world, especially the banks and places like that, you might have come across Oracle Coherence. But then there's Pivotal Gemfire, and there's us, Hazelcast. So I did a bit of work for Hazelcast as a solutions architect, and they decided I was scaring the customers, so they made me a product manager. And that's what I do today. Let me move on. There we go. So I won't keep you too long, because I know you want to all go down the pub. So what we'll talk about is a quick bit of history about Hazelcast, what is an IMDG, and what constitutes the functionality of an IMDG. We'll take a quick look at the features, because it really is a mixed bag of stuff. IMDGs, they're kind of like distributed systems toolkits. There's lots of APIs to play with. We'll talk a bit about the community. And then there's the one sales slide that I always have to put into these things. So we'll skip through that real quick. But if you do want to give me some money for something, support or something, then come and see me afterwards. But then the bulk of this I really want to be about, almost be like a technical training session, really. And we'll do some, how to install Hazelcast on your laptop, get a cluster up and running on your laptop, and then we'll look at Go Client connectivity, and we'll go through some Go samples, and we'll talk about the roadmap as well. So that's that. Oops, I've just exited. There we go. So, and I'm not quite sure I'm going to code and hold this microphone at the same time. Has anyone ever attempted to? Oh, you can be my glamorous assistant then. Okay. So just a quick bit about the history. It was founded way back in, it was about 2004, 2005. A couple of guys in Istanbul, actually. The only IMDG in town at the time was Oracle Coherence, I think. It was called Tangasol at the time. And these two guys in Turkey decided they wanted to not pay exorbitant Oracle fees, and came up with an open source solution and coded that. The core of the Hazelcast cluster, it's all written in Java, but you don't need to worry about any of that stuff. So that came along. It went over to VC-funded stuff in about 2014, offices in Palo Alto. And so now today we're looking at about 40 million phone homes a month we get from these are Hazelcast cluster instances that fire up. So they ping back with a version check. You can turn that off, by the way, if you want to. But where we ping back, we get about 40 million of those a month now, and we've got about 135 customers. So it's quite a nice little open source success story, really. So what is an IMDG? So that's the marketing blurb. So I won't go through that. But an in-memory data grid, really, it started out just as a caching solution, so a distributed cache. So you'd have used things like, you might have heard of EH cache or single process caches. And An in-memory data grid, the first element of an in-memory data grid is a distributed cache. So it's the ability to start many, many processes that form a cluster, and you can put data into that cluster. And we then automatically scale for you. We scale for you, and there's the idea behind it as well is the scalability is a very, very easy thing to do, and I'll demonstrate that to you. So if you've ever worked with something like Redis or you've tried to scale some of these other NoSQL solutions, you'll see how easy it is to scale an in-memory data grid. The data is stored entirely in memory, so when you're when you're accessing it, it's very, very fast. It's not generally persisted to disk, so you'll be using it for transient caches. However, one of the main use cases of in-memory data grids and how it really came to be was as a front end over a very, very slow database. So I'm pleased to see that a lot of you have come from the Ruby world and you're learning about Go. So you'll have experienced lots of problems with slow databases and how databases can be a bottleneck in your application. So this was really one of the first use cases that really brought in-memory data grids to prominence, was the ability to sit in line with a transaction that's going to a database, and it goes via an in-memory data grid first, and then the in-memory data grid, if there's a cache miss, can query the database. And it does that all transparently for you. You just wire it through, and it will do that for you. So you just do a query against the in-memory data grid. If it's not in the cache, the in-memory data grid will take it for you from the database. So that's really one of the first use cases. So we now have this product, this IMDG product, that is storing lots and lots of data in memory. It's generally key value stores, so maps, but there are lots of other data structures, and we'll look at those as well that you can use. So we're at this place now where you've got data in memory, you're grabbing it over the network from clients, and it's going back and forth over the network. So then someone come up with the bright idea of, well, why are we bringing all of this data back to our application to process it and place it back in the cache? So this is where distributed functions came along. So with in-memory data grids as well, you can write a function that will execute on the data. And not only that, if you give it a set of keys or you tell it the data that you want it to execute on, the grid knows exactly where in the cluster to send that execution to. So you now have a way of mutating data where it lives in the cluster. So that's the second part of an in-memory data grid. So you can see now it's starting to, it's not really a database, it's not really a NoSQL solution, it's kind of a mix of a cache and a distributed compute platform. And the third pillar of an in-memory data grid is messaging systems started to get built onto inside of in-memory data grids, so eventing systems, and we'll look at that again in a moment as well. So that was the ability now for you to react to events in your cluster. So I have a client, it can be a Go client, for example, and I'm observing changes that occur inside the cluster. So I can say, tell me, give me an event back to a client when a balance drops below a certain value, a bank account balance, or it goes to a certain value. So you can react to events, so it's very reactive as well in terms of eventing. So they're the three things, the three pillars of an in-memory data grid. Now, as I said, it's scalable, so all you need to do when you want to add more, because it's everything stored in memory, obviously you need to add more processes as you go along. Now, these are JVMs. So if any of you have worked with JVMs before and Java, you'll know that there's this horrible thing called garbage collection that can come and bite you on the backside if you start to run very, very large JVMs. So obviously that's not ideal for something like using JVMs for data storage, and that's not an ideal scenario. So what you do in this situation is to give yourself scalability. You add more JVMs across more machines, and they form your cluster. So you have this horizontal scalability. And the other thing you get when you store data in distributed data structures, partition data structures, is we give you backups. So you'll save an entry in a key value store, you'll give it a key and a value, and Hazelcast or in-memory data grids, they will partition the data, so there's a partition table, and we'll place a backup somewhere else. So you do a map put with a key and a value, it goes off into the cluster, it goes directly to a particular JVM in the cluster, and Hazelcast will take care of placing a backup in another process in the cluster. Now those number of backups are configurable. By default it's 1, and you can tune how those backups work. So you get to decide whether a backup is synchronous or asynchronous. So a lot of people want to use asynchronous backups for speed. So there's only one network hop and they get the ACK back on the transaction. So that's really how we store the data inside. So, you know, it's, as I said, most people use this for database, covering over databases, but a lot of people now are using it just for microservices, actually. Microservices have given IMDGs quite a big shot in the arm as well. Where you want many different applications. So, and I'm glad we've had the polyglot talk actually today as well, because what you can do with something like Hazelcast, where it's got many different client languages, and with the eventing that you get with it as well, you can start to have messaging systems and the microservices and shared state and shared data, and it's all stored within the in-memory data grid. So we're starting to see a lot of architectural patterns with microservices now, using Hazelcast as the kind of hub of all of that. So I'll quickly skip through these slides. One thing I will say, and because they're kind of saying the same thing that I've already said, what I will do is I'll put all of these slides, I'll put them on the comments on the user group and share them on the Dropbox for you, so you can look at that. So, yeah, you can see that. That's okay, isn't it? It's kind of a lot of stuff going on here, but yeah, it's really complex. But what the thing that we're really interested in is you guys as Go developers, you're going to be using Hazelcast as a client server system. Hazelcast, because it is a Java, the Hazelcast member cluster processes are Java processes that can be started with an API command line. You can actually embed Hazelcast clusters inside applications as well. So your Java applications can become self-clustering as well. So that happens a lot. But generally, you can see across the top there, at the very top, they're the client platforms that we have. So you've got the Python, the Node.js, the Go, and they'll connect over a network protocol, and we take care of the serialization of objects for you. So you'll save something into the cluster, it'll get serialized and saved down into the cluster. This APIs line is really where we start to talk about all of the different data structures that you can use. There's concurrency structures as well that are coming along in Go. They're not quite there yet. So you can see that there's a wide range of, there's various different types of maps. There's ring buffers. Has anyone heard of ring buffers or used ring buffers before? Okay, yep, so we've got the ring buffers there. Hyperlog, I guess if any of you have used hyperlog in Redis, we've got that one as well. And then you've got these atomics, and you can see there's these concurrency things over here. So we have something called a global lock. So you can create lots of global locks within the cluster, and you can use that as a synchronization mechanism between different distributed applications. So the point I'm trying to make is that really, although you can use Hazelcast as a distributed data store and a highly available and resilient data store, a lot of people just use it for some of these concurrency primitives. So they'll use it just for the distributed lock API, or they might use it just for the atomic long, just as some kind of counter or ID generator. So there's really, the API lends itself to many different use cases. And then lastly, I was speaking about the messaging. So we do have some queues and topics APIs that you can play with, and actually they are available. The queue and topic APIs are available in the Go client at the moment. So you can, as I said, if you need to have some kind of queue that's distributed and highly available and is shared between different applications and different processes, it's a very quick way of getting up and using a queue. You don't have to go to all of that bother of spinning up, MQ or something like that. And then off the top of that as well, we've got the query. The query, you can do things like get on a key with a key value store, but then we also offer predicates where you can do querying based on certain values in an object you have. Just a small salesy piece. what you see here in the, well, it's supposed to be orange, but what you can see there, that's all of the open source stuff. So you can see that the bulk of it is open source. And then the blue pieces off to the side, they're some of the enterprise pieces. So basically, Hazelcast makes its money by, you can buy support on the open source. So if you start up clusters, Hazelcast clusters, you can buy support on the open source, or you can buy a license for the enterprise edition, which gives you a few extra features that you can see over there. Okay, so I think we've already been through the clients, but we're building more and more client libraries. We have an open protocol, so it's a published protocol client on the Y protocol. So you know, whenever the next language of the month comes along, we'll be able to quickly create it. But we're seeing a lot of traction with Go, even though it's only been out for, I think, about 6 or 7 weeks. So 0.1's been out 6 or 7 weeks. 0.2 has just come out only yesterday, and we'll talk about that as well. The other big one, I mean, obviously Java is our bread and butter, and it's our most popular one, but Node.js seems to be quite popular. So we're doing a lot of stuff with Node.js. Because it's a JVM, the cluster itself, it can run on a lot of places. We have Docker images, so you can fire up Hazelcast Cluster from Docker images on your laptop, and we'll look at that. The one thing about when you try to create clusters, and if you try to create clusters with other types of software, is how, when you're doing this stuff in the cloud, how do these other processes find each other, and how do they mesh together in a cluster? Because you'll often find that multicast is not available, and obviously these things generally try and talk via sockets. So you know, you're not going to know the IP addresses of these things to mesh them together in any kind of configuration. So this is where we then plug into things like Zookeeper, etcd, Amazon Web Services. You can fire up a cluster in AWS, and that will use tags, you know, labeling, and you can create a cluster using labels. And then I think there's someone from Engineer Better here. Yes. So I think we work with you guys on the PCF stuff, don't we? Yeah, yeah. So Hazelcast works on Pivotal Cloud Foundry, and thank you to the wonderful people at Engineer Better. They've helped us make that happen. And also on OpenShift as well is a very popular platform. And then obviously Kubernetes is sitting on top of both of those. So just very, very quickly about the community, and then we'll actually get into some code. So you can see there, that's just demonstrating that really we've had some great growth, and in 2017 especially, you know, the phone homes are hitting the 40 million mark a month now. So there's a lot of people using Hazelcast. The company is split. You know, there's the open source side of things, and then there's the business side of things. So the open source and the place that you guys want to go to is hazelcast.org. So that's where you get all of your open source goodness. If you do have a lovely checkbook, though, you want to go to hazelcast.com, and that's where you can talk about support and enterprise features. So please don't go. I've had lots of complaints actually where people have gone to hazelcast.com and said we're too commercial. So go to hazelcast.org. We can skip over that. We can just very, very quickly look at this, but this is just trying to make the point that now, you know, Hazelcast in-memory data grids are used by, you know, the London Stock Exchange, most of the investment banks you can see there. Gaming in-memory data grids are very popular now. And actually, Internet of Things, IoT. So does anyone have a Hive British gas temperature thingamajig? Yeah, that's going through Hazelcast. So when it sends up all of its information, that's going through Hazelcast. And then there's a few other things there. So it's quite well used. And as I said, it's an embeddable piece of software as well. So this is mainly in the Java world, but we get lots of people OEMing Hazelcast and embedding it and hiding it away in their own software. So chances are, you know, I mean, do you guys, anyone use Atlassian and Jira? I know there's mostly people who hate Jira, and yeah. But so Jira and Confluence, that's when you're using the enterprise versions of that and the cloud versions of that. Hazelcast is behind that, providing various caching. People like SunGuard. So it's an embeddable piece of software as well. And actually, we do sit inside some ATMs as well. So this is the one sales slide. So as I said, it's you can use the open source, you can download it, you can use the Hazelcast clusters, you can use the Go Client library, and you never have to pay us a penny. If you do want support, the lowest level you can take is the Pro support. That's based on the open source libraries, and you get the SLAs. And as you move into the 2 enterprise editions, they're the things with the extra features and the shorter SLAs. So basically, you get these. Things like WAN replication, there's security, and a few other things you get there. So, now, where's my glamorous assistant? So, hello, what's your name?
Florine.
Florine. Hi, Florine, thank you.
Yep, you're welcome. Getting used to this by now.
Okay, so there are a number of ways of installing Hazelcast. The good old-fashioned way is if you go along to hazelcast.org and download and you download the zip file. So if you download the zip file, you extract that, you get a bin directory, and there's a start script there, and you can start a Hazelcast cluster member. So I wouldn't recommend that because that's kind of going away soon. What we are doing is we're doing package. We're trying to start delivering in package managers now. Guess a lot of you use Brew, do you? Mainly, yeah, good. So this is actually something you could really help us with, actually, if you wouldn't mind. If you do want to play around with Hazelcast, give our Brew package a test if you wouldn't mind, because you can see at the moment it's on our own tap. It's going to go up to the Brew Central repository soon. So you just do Brew install Hazelcast member. So I can hold that for a second, actually. And what that will do is that will give you a Hazelcast member command line, and you just execute Hazelcast member, and it starts a Hazelcast Java JVM on your laptop, and we'll look at that in a second. And then there's Docker images, so you can on your laptop as well. Again, if you wanted to fire up lots and lots of Docker images, you can build a Hazelcast cluster in that manner. And the way that they all actually, when you're building up the cluster, there's a default configuration file, and we'll look at that in a moment. Out of the box, it's a really nice experience. You can literally you can actually have maybe 2 or 3 commands, and you'll have a Hazelcast cluster running. It will be talking to each other, and you'll be able to start writing a piece of Go code against it and save some data into it. So actually, why don't we do that now? So let me just slip over here. So we're going to use this Brew package that I've already installed. It gives you this Hazelcast member command. So you can do basic things like start, stop, look at the logs, and you can list the members in your cluster. Now, obviously, this is really more about getting a quick and dirty development environment on your laptop. If you're running this in production, obviously you're going to be creating a cluster over multiple machines for resiliency. But this is a really nice way of getting running. Let's come out of this. So, and I'm going to have to find my terminal. Here we go. Now, shall I boost that up a bit? How's that? Can you see that at the back? Is that okay? Yeah. Okay. Great. So if I just do Hazelcast member now. And we can do lists. So there's nothing running at the moment. So we'll start something. And there are a few things here. So there's auto completion, and so you can do things like start with verbose. You can start with a custom configuration if you want, and we'll show you the XML. Unfortunately, it's XML. I'm sorry about that, but there's an XML configuration file. So that there will just start a Hazelcast member. You can see it's using whatever Java I've got on my laptop, and it gives me a bit of information and an idea of what's running. So if I now say Hazelcast member status, there's that one process running. Now, as product manager, I've been complaining because I quite like the way that Docker does the the naming, because it's a lot easier to there's something in the brain, isn't there, that allows you to quickly look at that Docker name and quickly type it out. So this is a bit, meh, I don't like that. So we're going to change that. But if we start, so let me just show you. We're going to start another one of these now. So that started another process. So we've actually got a cluster now, believe it or not. So there's two JVMs that are running, and they're both sharing, the memory that those JVMs have got now are available to me to store data in. So I can change the, when I start this, there are various, so if I say Hazelcast member, there are various options here. One of them actually is on the start command, where you can set things like, obviously, the configuration file. You can set different ports and interfaces if you want on cluster names, but you can set Java options. So there's a small amount of tweaking you can do if you want to increase the JVM sizes that you're starting the cluster on. So if we just now look at the Hazelcast member, actually let's list out. So there we go. So I want to look at the logs, JN, XJ, so we're not seeing all of the logs here, but you can follow. There's a follow command where you can follow the logs. But what you've actually got now is out of the box, without any changes to configuration. We've formed a cluster, and you can see there we've got two members in the cluster. So to give you a bit more visualization around this, what I'll do is I'll start something that we call the management center. So it's kind of our management GUI where you can see data structures and what's going on. And it'll be a nice way of demonstrating how the high availability and the backups work as well. It will visualize that a bit better for you. So there is one caveat, and it's unfortunate at the moment that we don't have the management center as a brew package. So it's a good old-fashioned zip, unfortunately, for this. So the management center is a Java, is a JE application. So it comes packaged as a WAR, so you can see there's a WAR file there, or it comes with an embedded Jetty web server. So a quick way of running it is just to run this script, and it will fire up the embedded Jetty web server in the jar and start the management center. So we're up and running now. And let's go over, here's the login. And you can see it's there's a dev cluster running, okay? So we can connect to that. Let's boost this up a touch. So there's the two members of the cluster, and there's the JVM memory there's the max heap size of the JVMs. So all of that memory is available to me now to store data within it. And obviously I can horizontally scale this out as I need more memory. We don't see anything down here because we've not got anything actually stored in the cluster yet. So let's actually go over and get some Go running. So where are we? So I was too cheap to shell out for the JetBrains ID, and I can see you've got your JetBrains T-shirt on, so that's why I mentioned that. So obviously, first of all, we need to install the Go client. So there's the Go Get. So you can go along over to our GitHub repository. It's GitHub Hazelcast, and there's the Go client there. So you can do your Go Get to get that. And then within this same repository, there's a samples directory. And that samples directory gives you a sample piece of code for all of the data structures that we have at the moment in the Go client. So this is 0.2, so it's very, very early. You'll notice we don't have things like a lot of the distributed functions APIs. We don't have an awful lot of the atomics at the moment, so we don't have that distributed lock. But we do have most of the data structure. So you've got the maps, the list, the queues, and the replicated maps. And I'll talk about the replicated maps. They're slightly different in the way that the replicated maps work to our standard maps. So standard maps are partitions, as I said, where you have one value lives on one JVM somewhere, and the backup lives on somewhere else in the cluster. So you get this very nice horizontal scalability, and you're not bounded by one JVM. Replicated maps are the exact opposite. They're when you save something into a replicated map, that map entry is in every single JVM in your cluster. So The reason you would want to do that is really for distributed functions. If you've got static data that you want to use in your distributed functions, and you also, in that function, you're working on partition data at the same time. So some kind of business transaction function you want to run in your cluster, and you need to get some static data like some addresses or some kind of lookup tables. They would be replicated maps, and then your variant data would be a partition map. So that's really what you would use replicated maps for. So once you've gone over and you've got this and you've downloaded it, we can start to run some of the tests here. So that we've got the simple hello world test here, and so really the simplest piece of code is does VS Code have a presentation mode or anything like that? I don't think it does it?
Yeah, I can try zoom in.
Yeah, I'll just zoom in, shall I? Yeah. No, it's not working. No, it's not working. Well, so this is.
There's Zen mode. If you go to view up and then you see Zen mode.
Where's that?
There is a zoom in zoom out at the bottom.
Tell me when to stop because
One more, a couple more actually.
there we go. Toggle Zen mode. Okay. Now, am I going to be able to run this now? This is going to be the problem for me.
Command plus.
Okay. So I won't actually run this code, but what this is showing is really, this is about as simple as you can get in terms of what you're going to be doing with connecting to a Hazelcast cluster. Obviously, you import the Hazelcast Go client, and you create this configuration. So at the moment, on the Go client, we only have programmatic configuration. There will be, I think there's going to be a YAML configuration coming on at some point. So programmatically, you tell it where the cluster is, and then you go off and connect, and that gives you this client reference. That client reference is something called Hazelcast instance, iHazelcast instance. And off of iHazelcast instances where you can get references to all of your data structures. So you can create as many of these data structures as you want, as many maps as you want. If you don't have to have any kind of configuration, you can just say, get me a map, and I'm going to call it customers, get me another map, and we're going to call it accounts. And Hazelcast will use the default configurations. However, what you're going to want to do is those default configurations don't have anything like eviction on them. So obviously in-memory data structures, you need to be very, very careful you don't run out of memory. And the way you do that is you specify various eviction parameters. So what you have to do is you'll have to go into the XML, define your data structures, and give them eviction properties. So the eviction properties, the triggers for eviction are generally things like when the heap size of that data structure reaches a certain point, then you can start evicting entries, and the way you evict would be least frequently used or least recently used. But there's also callbacks you can have for eviction. So that's about the simplest piece of code. But let's actually look at let's exit Zen mode. So here's a piece of code that is actually working with a map. So you can see we're connecting to the cluster, and we've got our reference to the Hazelcast instance. And you can see here we're just saying get map, and then with the map name, and it's a map of greetings, and it will be putting into the key value store, and then it will just disconnect the client. So if you could just hold that. Oops, I don't want to do that. Definitely don't want to do that. So let's go into Hello World. It was 2, wasn't it? Here we go. And we'll go run to go. So that's connected, and that's placed over the, it's gone over the network, serialized these strings, and it's put them into the map. So that's placed 5 entries into that map. So if we now look at the management center, now the interesting thing is about how this goes about partitioning records. Now, we've got 2 members, but you can see that this line here, I'm in the greetings map here now, and you can see that here are the primary entries and there are the backups, and you can see it's quite strange that, why have we got 4 on one and 1 on the other? And that's basically the way that the partitioning works. We basically, the way that it works, and we decide, it's a predictable partitioning algorithm. So what happens is we take the hash of the key, and we mod it by the number of partitions we have in the cluster. And that for that particular key, it will always give you the same partition ID. So all the client then has to know is which partitions are owned by which members in the cluster. So the client, the cluster periodically sends a partition ownership table to the client, and it will say that partitions 1 to 100 are owned by this first cluster member, and partitions 200 to 300 are owned by the second. So the client then does a hashing algorithm with the mod by the partitions. It gets the same number every time for that key. So it then looks up in its table and it knows it needs to send that record to particular member. And that's why you sometimes see this slight slight mismatch. As you add more and more entries, and if you've got a good hashing algorithm on your key, then generally you should see it should balance out quite nicely. So what we'll do now actually is just to show you the way that this can scale out is, and bear in mind I'm doing all of this on the command line. So let's do another shell. So I'm just going to add another Hazelcast member now. So let's start another one. So we now have 3 in our cluster. So that will go off and try and form a cluster. So there's the 3. Now this is push on a low priority thread. So there you go. It's just come in, and here we go. So you can see now that that's rebalanced. So it automatically rebalances as you add and as you remove JVMs into your cluster. And a lot of people do this auto sizing when things are running in production. You generally don't see any kind of latency hit with your transactions while this sizing is going on. So especially with the gambling companies, they'll have this automatic scaling. They'll be running in the cloud. This is generally done by Kubernetes, but they'll be running in the cloud. They'll detect that there's an inflow. There's the Grand National coming up, right? So they'll scale up for the Grand National, and then they'll scale back down again. And that can all be done in a running production system. There's no downtime at all with this kind of scaling. So you can see really how easy it is to scale this thing. And then if you get, you lose a machine in your cluster, we put the backups on another machine. So the theory behind all of this is with the high availability, you can lose a machine in your cluster and you still maintain your data. And also we allow you to choose racks as well. So you can choose ranges of IPs if you know those to house your backup. So you give us 2 ranges of IPs. So one might be on one rack and one might be on another, and then you can give yourself rack resilience as well with your high availability. So I'll just show you how are we doing for time, by the way. Yeah, wind up. Okay. So I won't. So you can play around quite quickly. Those samples have, there's topics and queues and other things and you can look at them in the management center. So that's really where we are. I just want to tell you what we're going to be doing in future versions. But by the way, in these slides, I show you how to start up in Docker and also Kubernetes. We run quite nicely in Kubernetes. There's also, so that's where we are at the moment with the Go client today. We do have event listeners as well, so you can do this eventing that I was telling you about. You can react to keys and data changing, and we'll show you the old value and the new value. So you can send that information back to a client. We do have queries with predicates today. Where we're going in the future is we're going to be introducing some things called CRDT counters. So I don't know if you've ever heard of CRDTs and what they are. They're quite an interesting structure. Flake IDs as well is a really nice way of creating IDs in a system, in a distributed system. We're going to have projections and aggregations, so you don't have to, when you query something, you don't have to return the entire object. You can just return part of the, the field. This last one is really the killer, where we start to give you real big performance improvements over writing your application against, say, like a Redis or a MongoDB. And this is the ability to have a near cache actually in your Go client process. So you can configure a near cache. So when you do that, we saw that map put where he's putting in the values. When you do a map get, what we can then do is you do a map get, it goes off to the cluster, it retrieves the data, and then it stores it in a small local cache in your Go process. So the next time you go to get those keys, it will first of all look in your Go process for the data, and you can configure eviction inside that. So it's kind of like a nice small little near cache that you can keep near to your application. It prevents you from going down to the central cluster and having all those network hops. So this is where then we, if you compare this to something like a Redis system where you're going back and forth over the network all the time, this is where you'll really start to see your performance gains. So that's that. We're on Google Groups, so ask questions in Google Groups. We're also on Gitter, so if you want we have all of our engineers hang out on Gitter. That's a very vibrant community. And that's it. So I've got to do, there was about 5 or 6 of you that were foolish enough to give your names to the marketing people. And I was going to randomly pick one out, but based on the fact that I could only read one of the names on here, some of the writing is absolutely disgraceful on this list. So based on the fact that I could read Chris Augier's name. Where's Chris? Is he here? Please let him be here. He's gone. Okay. So Paddy Steed is the next one. Where's Paddy? Oh, that looks like favouritism, doesn't it? Well, there you go. You've won a £50 card, and I think I should give you a T-shirt. So there's a T-shirt here, and then we've got maybe 2 or 3 others. So whoever wants a T-shirt. Sorry, there's your card here. Sorry. Yeah, why don't you hand those out? There's your card. There's stickers over there. I'd really appreciate if you could help us out by really kicking the tyres on this Go client. Actually, we're making a big investment in this in terms of engineering. We're on 0.2. We're going to drive towards a 1.0, what we feel will be a production-ready system. We want to get to that by the end of the year. So it'd be really nice if you could kick the tyres on it, and it'd be super wonderful if maybe this time next year I'm hearing about Hazelcast being used in Go applications. Really only scratch the surface. We do free training as well, because as I said, it's a very complex API. But let's just do some quick questions, yeah. No, this is purely for the community. We're doing this, yeah. Although there are customers who are asking for it. We're not doing it for them, but there are a number of very large companies in America that have asked us for a Go client.
Just curious about the way you're approaching the API exposure.
The roadmap.
The memory objects or the concurrency objects. Given that Go has a lot to say about concurrency, it seems to be a bit odd to skip the concurrency this early on.
Yeah. It's purely the way that there's no hidden agenda really behind it. It's purely around the way that I spoke about this open protocol that we have between the client and the server. It's purely the quickest thing to do first is the data structures. So we've done those first to get it out to the market, and it seems like quite a useful thing for people to be able to store stuff in a distributed high availability system. But the concurrency things are coming. They will be coming along. Yep.
So I kind of have a few very specific questions to my use case. So for one, is the data store schemaless, or is it just kind of like random document, or do you have a structure? Yeah,
so that's a good point actually, and I should have made that point. It is schemaless, so you just store. Hazelcast has no knowledge of the objects you store within it, so it just takes binary and it stores the binary with a key.
And on top of that, do you have any mechanism to support secondary indexes on schemaless data?
Well, we don't support secondary indexes, but we do try to index the binary object, the value that you store with us. So there's a primitive indexing around it, and we need that because of the predicates. So you can write a predicate which will select out data based on some properties of the object, but there's no secondary indexes yet, no.
Okay, and a very, very specific question. So a current problem I have is that I'm basically having to store keys in UTF-8 encoding, and we effectively have keys that can be stored as uint64s. And right now, having to store UTF-8 versus actual raw bytes will save us a few hundred gig across the cluster. So can I store non-UTF-8 keys
Yes, yeah.
Fantastic.
Anything that you can serialize, you can store
as the key? I can
Yes,
index by
as the key.
non-UTF-8.
as the key.
Okay,
Yeah.
fantastic.
Yeah.
Thank you.
Yeah. Yes.
Quick question. So how do your engineers find working with Go versus the other languages to produce the
Well, so the question was how do our Hazelcast engineers find working with Go compared to what is our core competency, which is really Java. So the question or the answer to that is that the people that have written the Go client are not Java developers and have never used Java. They're actually two recent graduates out of one of the universities in Istanbul. I didn't really go, well, I kind of alluded to the history of the company. We have a bunch of engineers in an engineering centre in Istanbul, which I get to visit every couple of months. Very nice place to go to Istanbul. And then we have, engineers around the world. So actually, if you're into solving hard distributed systems problems, we are hiring engineers. Sorry, I forgot to point that out earlier. So we get, you get to do really cool things like working with CRDTs. If you're into your consistency algorithms like Paxos and Raft, and you like to sit on tube trains and read academic computer science papers about distributed systems, then come and speak to me. Yeah.